Final exam review number 3 is going to deal with conics, or our circles, ellipses, hyperbolas. And we started this lesson with the distance between 2 points. So if I have 2 points and I want to find the distance, we'll use the distance formula, which is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So in this example, we'll take -3 minus 4, square that, plus 2 minus 5 and square that. Here we'll get -7 square it, we'll get a 49. -3 square it, we'll get a 9. So the distance is the square root of 58. We also looked at the midpoint between 2 points. The midpoint is just taking the average between 2 points. So add up the x coordinates and divide by 2. Add up the y coordinates, doesn't matter really which way you go, and divide by 2. So again, if we take an example of this, the midpoint between 4 and -3 will be a 1/2. The midpoint between 5 and 2 will be 7/2. Then we got into looking at equations. The easiest equation that we looked at was a circle. Let me give you the standard form of a circle is x minus h quantity squared plus y minus k quantity squared equal to r squared, where if we have a circle, the center is hk, the radius is equal to r. So we did a couple different things here. We graphed circles, we put things into circle notation. If I give you that we have a circle at the origin and it passes through a particular point, this is one way that we use this equation. And when we look at the equation, if the center is at the 0, that's this point. So the origin, remember, is 0, 0. So we would just say x minus 0 squared plus y minus 0 quantity squared. And we need to know the radius. So if we have a circle that passes through this point with center equal to 0, 0, we'll need to know the distance between those 2 points. And what makes it nice between 0, 0 and this point, we'll use our distance formula, which is, again, 7 minus 0 squared will be 49. -1 minus 0 will be -1 square that, and we'll get a 1. So the distance, this distance right here would be the square root of 50, but when we stick it into our equation, square root of 50 squared will just be 50. Graphing, graphing a circle. If I have x minus 1 quantity squared plus y plus 5 quantity squared equals to 4, understand that the standard form is we'll see the center. So the center will be 1, -5. And don't forget, when you take the radius, you have to take the square root of this number, which would be 2. So the easiest way to sketch is just sketch the center first, go up, over, and down, and graph your circle. So that starts off our conics. We'll get into ellipses and hyperbolas. Pause, make sure you're caught up. Next, I'll give you the standard form of an ellipse and then remind you how we graph these, how we get different equations. But this is the standard form. The center will be HK. Remember that A is the distance that will move in the x direction because it's underneath the x. B is the direction that will move in the y direction because it's underneath the y. So one thing that you'll need to do is graph an ellipse. So if it comes to you in standard form, and we'll have perfect squares usually under these. So when we graph, we'll have to identify the center. The center in this case, again, remember we'll go opposites. And we'll graph our center. We'll go in the x direction 6. We'll go up and down 4. Graph in our ellipse. Might not be exactly to scale, but remember how we label these. The longer an ellipse are the vertices. The shorter are our covertices. If I give you an equation, how do you know if we have a ellipse or a circle? We don't have equal coefficients of our x squared and our y squared, so we have an ellipse. So the first thing that we're going to have to do here is get it into standard form, which makes this equal to 1. So if I divide everything by 81, it'll look more like a standard form. So we'll have x squared over 81. 9 goes into 81 exactly 9 times equal to 1. Okay. Now notice that our center doesn't have any points, so it'd be just 0, 0. We're going to move in the x direction 9, so the vertices will be at 9, 0, and negative 9, 0. The covertices are the smaller. It moves in the y direction, so we'll get a 0, 3, and a 0, negative 3. Hyperbolas look the same. The biggest difference here is that we'll have a minus sign. If the x squared is first, we'll have a hyperbola that opens right and left. If the y squared is first, we'll have a parabola that opens up and down. Okay, so look for those. If I give you a standard form, we'll do like we did kind of with the ellipse. So the center is at 0, 0. Because the x squared is first, that's where we'll find our vertices. We'll have our hyperbola that will kind of open to the side, and we'll go in the y direction 2, and we'll get these asymptotes, our guidelines of how wide to make our hyperbola. So graphing hyperbolas, you'll have to identify the center, and you'll have to identify the vertices. The vertices are always on your graph. So this time we're going in the x direction because it's first, and then you just label the vertices. The last type of problem we saw in this section was finding where these conics intersect. And this is bringing in a concept that we learned last semester as well. And we have a system, so we're trying to find the points of intersection. And probably the easiest way to solve this is with elimination, because we're going to try to see if I can combine these and get rid of a variable. So you might recognize that if I add y squared to negative y squared, I'll get 0, so I'll eliminate the variable. But 1y squared plus 1y squared will be a 2y squared. We're adding these, so we'll get a minus 32 equal to 0. Now let's just solve. So solve means find x. So I'll put the 32 on the other side, divide by 2. So x squared equals 16. So where are these two graphs going to intersect? When x equals 4. So when x equals 4, let's plug that back into one of these equations and see what y will be. So 16 minus 25 will be, a negative 9 equal to 0. Let's solve for y, so y will equal 3. So when we're solving, we're trying to find a point of intersection, and that's what this point is. This concludes your review on conics. I will give you standard forms that you can use on your exam, but you have to be comfortable with how to use those formulas.